All right, so continuing on in lesson 3, we're going to do a couple more examples of trig ratios solving for different side lengths on a triangle. And so I'll do this one and then 3 more. And from there, that should be good to get you going on the assignment. They're all just kind of variations of the same problems that we're doing here. So this one tells us that we're going to use the cosine ratio to solve, with the angle 35 to solve for what this x is. Now, later on, it's not going to tell us which ratio to use. We're going to have to figure out which one we want for ourselves. But the cosine ratio, remember, if we use our SOHCAHTOA, the ka for cosine is adjacent over hypotenuse. Okay, so cosine, we write COS, of the angle 35 degrees is equal to the adjacent side over the hypotenuse. Okay, so adjacent is going to go on the top and hypotenuse is going to go on the bottom. So if we're looking from this angle here, this is our adjacent side. This is our hypotenuse. And so adjacent is the one that's going on the top. That's our 8. And hypotenuse is going on the bottom. That's our x. So we learned from the last, in the last video that we can, when we have things set up this way, we have no addition or subtraction or anything, we can move things diagonal across that equal sign. So we want to get that x to be on the top. Right now it's on the bottom. So we can move it across the equal sign diagonal to be up on the top of this one here. Then we need to get rid of that cos 35 because our x is going to be here, but we want to get rid of that cos 35. So we're going to take that and we're going to move it down diagonal to the bottom of this one. So these are just swapping places. Okay, you could do it in 2 steps if you want. I'm just going to do it in 1 here. Cos 35 has been completely moved to the bottom. There. So now this is what we're going to put in our calculator. 8 divided by cos 35 degrees. So if you do that, it will look something like this. Something like that there. Sorry. Light's glare's a little bad there. And of course it powers off at that moment. Okay, you get the idea. In your calculator, you're going to write 8, then divide it by, so it'll look like a slash, and then cos 35 degrees. Make sure you're in degree mode. If you've set your calculator recently, it won't change back to radian mode. It's just if your calculator gets reset that works. This is what it's going to look like in your calculator, and that will give you x is equal to 9.76, which I'm just going to round up to 9.8. 9.8. So that is the length of this side here, is 9.8. So that brings us to the next 3 problems. So these ones here do not tell us what trig ratio to use. We need to figure out that for ourselves. So it says, calculate to the nearest tenth the length of the indicated side. So for problem A here, we are trying to figure out what is this side length. Now, we are given this angle, and we're given this side. So we're going to use this angle for our trig ratio. And so we're going to label our sides based off that. That would make this the adjacent side, which we don't care about for this one. And this is our opposite side. And this is our hypotenuse. So then thinking about our SOHCAHTOA, right? Our SOHCAHTOA will guide us into which ratio to use. So we'll say which one of these 3 ratios uses opposite and uses hypotenuse. Okay, adjacent we don't know and we don't care about, so we're not going to use the adjacent one. The only one that uses the opposite and hypotenuse only is which is our sine is opposite over hypotenuse. So we're going to use that one. So we'll say sine of our angle 68 degrees is equal to the opposite over the hypotenuse. Okay, so the opposite is the one that goes on the top and the hypotenuse on the bottom. It's always that first letter here, and it's on your formula sheet there as well. So 9.7. And A is going on the bottom. That is what we are looking for in this case. So now we just need to solve for A. So we need to get A on the top by itself. So I'm going to move this diagonal across the equal sign up to here. And we're going to get rid of that by moving it down to the bottom of the other side. Okay, so these end up just swapping places. And so that leaves us then with A is equal to 9.7, hasn't changed, it's still on the top there, over sine 68 degrees. So in your calculator, you're going to say 9.7 divided by sine 68, and that will give you the length of that side. 9.7 divided by sine 68, and I get 10.46, so I'm going to round that up to 10.5. So A is equal to 10.5. And that's our final answer. This thing here is 10.5 millimeters long. Okay, so we should write our units in as well, millimeters long. So then we get to our next problem. Okay. This one here, we're looking for side B, and we're given this angle 73 here, and we know this side here. So this is our opposite side. This is the hypotenuse across from the 90, but we don't care about that one for this one. And this one is our adjacent side. Okay. Now, we're going to look at our three trig ratios to figure out which uses opposite and adjacent. So we're going to need to figure out if we need sine, cos, or tangent. The one that uses opposite and adjacent is tangent. Okay, tangent, TOA, tangent is opposite over adjacent. So that's the trig ratio we're going to use. And we'll set that up. Tan 73 degrees is equal to opposite 8.7 over adjacent, which is B. We're going to do the same thing we did here. We're going to swap these two diagonal. B is equal to 8.7 over tan 73. And that's what we put into our calculator. 8.7 divided by tan 73 is equal to 2.65. So I'm going to round that to 2.7. Okay, so this side here is 2.7. And this one is centimeters long. That is this side there. So our last one, we are given this angle. This is our hypotenuse, and this is our adjacent. Okay, so then we're going to look which uses adjacent and hypotenuse. We want to figure out what the hypotenuse is. So not sine, because that one uses opposite. Cosine is adjacent over hypotenuse. That is the one we want. Okay, it uses both. So we'll set up our cosine ratio. Cosine of our angle 31 degrees is adjacent over hypotenuse. It's equal to adjacent is 21.4, and hypotenuse is C. And we do the exact same move here. Now, be warned that the variable is not always on the bottom. Sometimes we are looking for the top number, so be careful that when you're doing the assignment problems that sometimes it will be the top number that we're looking for. In this case, we're looking for the hypotenuse, so that's on the bottom. But if we had this as a variable and this as a number, right, if our adjacent was what we were looking for, then we would have the variable on the top. And all we need to do is just take the bottom one and move it over. So anyways, to get this by itself, sorry, this is getting cut off a little bit on the edge of the screen there, but you'll get the idea. We're moving that up to the top of the other side, and that's getting moved down diagonal across the equal sign to the bottom. So C is going up, the cos 31 is going down, and we'll end up here with C is equal to 21.4 divided by cos 31. That's what we put into our calculator. C is equal to 21.4 divided by cos 31. 21.4 divided by cos 31 equals 24.96. So I'm going to round that up just to 25. This one was talking about centimeters as well. So we found the length here. It's this length of this side is 25 centimeters. So that should give you a bunch of examples to work off of. The practice problems are all going to be similar idea. Okay, if you either write out your SOHCAHTOA or have your formula sheet right in front of you, so that you use that to pick which ratio you're doing, and remember to be careful which one is going on the top and the bottom. So for this one here, I can see that this one is actually going to have the variable on the top. This one is sine 8 degrees cos. Cos of 8 degrees is equal to adjacent over hypotenuse, and I just completely lied. Okay, this one is on the bottom. That's 46 over E. Nope, all those are on the bottom. Okay, sometimes it's going to be on the top. You've been warned. So good luck on the assignment, and I'll see you in the next one.